Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at the topic the mole, and we are going to be looking at redox titrations. So we are going to look at what redox titrations are. Then we are going to look at two examples of redox titration calculations, and then we call it a day. So you look at what redox titrations are and practice question. So standardization is a process through which an unknown concentration of a solution is determined by use of a standard solution. So a redox titration is a process of determining the quantity of a sample by monitoring a redox process until the end point is reached when all the sample has reacted. So when you look at a redox process, we are reacting two substances that undergo oxidation and reduction at the same time. And the most common oxidizing agents are potassium permanganate 7, which is purple in color, and potassium dichromate 6, which is yellow in color. So when this redox reaction occurs, these colors usually change. For the potassium permanganate 7, it turns to a colorless solution, while potassium dichromate 6 changes to a green solution. So they are oxidizing agents, so it means they are reduced in the process. So an example of a question, you'll notice this question has been compressed. It's a titration question, but it is compressed. So we are going to look at the question and then we'll look at one titration question. So find the concentration of iron 2 sulfate solution given that 25 centimeters cubed of the acidified solution required 19.8 of 0.02 molar potassium permanganate 7 for complete oxidation. So we write first of all what we are given. We have iron 2 sulfate and we have the potassium permanganate 7. So for the iron 2 sulfate, we have been given the volume, which is 25 centimeters cubed, and we have been told to calculate the molarity. So we know that molarity is equals to the number of moles of a solution per volume over volume, and this volume is in liters. So if you look at this process of calculating molarity, it tells us that we need moles and we also need volume in this calculation. So if we need moles and volume, in this question we don't have moles, we only have volume. So we need to figure out a way to get moles. Let's look at what values we have for potassium permanganate. We have the volume, which is 19.8 centimeters cubed, and we also have the molarity, which is 0.02 m. So using these two values of molarity and volume, we can be able to get the moles for the potassium permanganate, and then we get the mole ratio and do this calculation. So we will say if 0.02, we know 0.02 molarity in the first principle means is 0.02 moles, which are in 1,000 centimeters cubed or 1 liter. So what about 19.8 centimeters cubed? We cross multiply. So we get 0.02 times 19.8 divided by 1,000. This gives us 0.000396 moles. So if you look at the equation, you'll notice the mole ratio for the potassium manganate 7 is to the iron. You'll notice the mole ratio is going to be 1:5. So we already have the moles of the permanganate 7, which is 0.000396, and for the iron, which is now the ratio is 1:5. So if you want to get the moles of the iron, we are going to say 0.000396 times 5, which is going to give us as 0.00198 moles. Now we have the moles of the iron. We go back to molarity. We can use the formula molarity is equals to moles over volume, or we use the first principle method. So if 0.00198 moles are in 25 centimeters cubed, since those are the volume that was used in the reaction, so what about in 1000 centimeter cubed? We crisscross multiply, you get 0.0198 times 1000 divided by 25, which gives us 0.0792. So we are going to look at a titration question. So we are only going to look at the part 1 of this titration question. So we have acidified potassium permanganate 6, solution A, and 0.1 iron 2 salt. So we are going to use these two solutions. You're not going to use this in this case. So you are required to standardize. So we are going to standardize potassium permanganate using iron 2 salt. So the burette was filled with solution A, which is the permanganate, and 25 centimeters cubed of solution B, which is the iron 2 salt, was pipetted and placed in a conical flask. And of course, a few drops of the phenolphthalein indicator was added. And then the solution A was titrated with solution B until the pink color appears. So the results were recorded in our table as shown. So definitely the first question is going to be calculating the average volume, which is going to be 20.0 plus 20.0 plus 20.0. You divide everything by 3, which gives us 20.0 centimeters cubed. The next question is how many moles of solution B or the iron salt are present in the 25 centimeters cubed solution. So we know the molarity of solution B is 0.1 molar. That means it's 0.1 moles were in 1000 centimeters cubed. So what about in 25 centimeters cubed? So that is going to be 0.1 times 25. We divide by 1000, which will give us gives us 0.0025 moles. Solution A were present, so you're calculating the moles of solution A present in the average volume, assuming 1 mole of B reacts with 5 moles of A. So 1 mole of B reacts with 5 moles of A, so the mole ratio of B is to A is 1:5. So we already have the moles of B, which is 0.0025 moles. So to get the moles of A, we'll say 0.0025 times 5, which will give us 0.0125 moles. And then the last question is calculate the molarity or moles per liter of solution A. So we have just said the 0.0125 moles of A were in the 20 centimeters cubed, which is the average volume. So what about in 1000 centimeters cubed? So it will be 0.0125 moles times 1000 divided by 20, which will give us 0.625 moles per liter. So that's it. I hope you've been able to see how we did those calculations. Either way, if you are given a general question that has been summarized for titration or a titration question, the most important thing that you need to know is the mole ratio for the reaction of this oxidizing agent. Most of the time, these equations are usually given or you're given some guideline, but you can look at how the equation looks like so that you can be able to know the mole ratio. The moment you know the mole ratio, then it will be easier for you to be able to calculate the moles of the unknown solution. So you notice standardization does not fall only on the direct titration, it is still also used on redox reaction. So that brings us to the end. So see you in the next lesson as we continue with the different types of titrations.